Second situation now. We're going to accelerate up the incline. So that means that we're having an applied force pulling up. Let's just look at the kind of question this would be. Let's try a pen that works. There we go. Let's have an incline of 11 degrees. And let's say that it's like a skier being pulled up the incline with some applied force. I guess we'll give the skier a head. There he is. Let's make the skier weigh 100 kilograms. So if we just look at our situation here, if he's being pulled up the incline, then we've got a force of friction that is opposing that upward force, plus when we draw out all our components, we have Fg, Fy, and Fx. This Fx can slide up here as well. So there. That's all the forces that are on there. And we also have an upward normal force, Fn, which I'll find eventually. So let's see. What we're going to do is we're going to find the applied force if the person accelerates upward or up the hill at positive 1.5 meters per second squared. So we're just saying that they're moving upward positive 1.5 meters per second squared. So there we go. All right, first we're going to find our Fx, then we're going to find Fy, then we're going to find our force of friction. Those are the three things that I'm going to do first. I, though, think that with this picture drawn, maybe it's a good idea for you to push pause, give it a try. Okay, hopefully you got an answer. So let's see, what do we get for Fx? Well, I remember that Fx is Fg sine of theta. So that's going to be 1,000 sine 11 degrees. So Fx is going to be 190.8 newtons. I'm not going to bother throwing any negatives on here just yet. I'm just going to leave it as 190.8. My Fy is going to be Fg cosine of theta. So Fy is going to be 1000 cosine of 11 degrees. So Fy ends up being 981.6 newtons. And again, not going to be putting any signs on that. Last thing, I'm going to find my force of friction. I know that that's equal to mu Fn. And I look at this, I forgot to tell you what your coefficient of friction is. I'll tell you now, it's 0.11. Okay, so that's what the coefficient of friction is for that surface. Remember that your normal force is equal to your Fy, so actually I can just say this. So my force of friction then is going to be equal to 0.11 times my 981.6. So my force of friction ends up equaling 107.9 newtons. You cannot use tangent of theta here. Okay? This whole thing is wrong. You'll get the entire question wrong if you do that, because that only worked if it was constant velocity or no acceleration. Not the case anymore. Okay. Second, I'm going to find my applied force. The reason why I found all these forces is because I can take this thing, I can just tip it to the side so you can see our old type question here. And what I've got is a blue this way, a blue that way, and a blue this way. So I'm going to do that. I'm going to do a sum of F. Okay, so a sum of Fa, or no, sum of my forces is going to be equal to, well, let's look at this. That minus this minus that has to equal my mass times my acceleration. So Fa is going to add 2 minus Fx, which is going to add 2 minus Ff equals mass times acceleration. Fa I don't know. Force in the x direction, I just figured it out, 190.8. Force of friction, I just figured out, 107.9. Mass, I know, 100 kilogram skier. Acceleration, I was told in the question, is 1.5. there. So you're going to end up getting 100 times 1.5, that's 150, added to 190.8, added to 107.9, so your applied force ends up being equal to 447.9 newtons up the hill. Or you could have put a positive here, it doesn't really matter to me. There's your answer. And remember from our general pictures, when the thing accelerates up the hill, we said that FA had to be greater than the Fx plus FF. So that was kind of our FA greater than Fx plus FF. And just have a look. Does Fx 190.8 plus 107, oh yeah, 447 is definitely bigger than that. So at least we know we're possibly right. If you'd have got this to be 85 or something weird like that, then you know that you're in the wrong, you're totally wrong. There you go.